Here's a fun problem. We're going to go to see an outdoor movie, maybe to a drive-in theater if you can find one. There's not many around anymore. Let X be the width of a movie screen. Let Y be the length. Let 800 feet be the amount of LED lights on a string that we need to frame this giant screen. What is the largest possible area of the screen? Okay, so let's see how we're going to work out this word problem. We want to express the area, A, as a function of only one variable, X. So that's our goal. Let's see. We know that area, it's a rectangle, of course, and we know the area will be equal to X times Y. Do you see that blinking up there on the top line? That's what our lights are going to do when we get them up. I don't know what's going on. Okay, we need to get rid of the Y in A equals X times Y. Well, we're going to use the fact that the string of lights is the perimeter that will go around the rectangle. And they told us it's 800 feet. Okay, that perimeter is described as 2 times X plus 2 times Y. 2 times the length plus 2 times the Y gives you the perimeter around a rectangle. So let's solve for Y. 2Y equals the negative 2x when we move it over, plus the 800, and then I'll divide everything by 2, and we get y equals negative 2x plus 800 divided by 2. Now, you're going to factor a negative 2 out of the top, a positive 2. It'll leave 2 parenthesis negative x plus 400, close parenthesis. Then you're going to cancel a factor of 2 on the top and bottom. It gives you y equals negative x plus 400. So there's our y in terms of x. We're going to substitute that back upstairs into the A equals x times y. That way we'll have the area as a function of only x. So it's x times this new value for y, which simplifies to negative x squared plus 400x. That's great. We have our area in terms of only x values. Okay, so it's just a function of x, and we're going to give it a new name. The area we will call, well, since it's a function of x, let's call it f of x. Our area we will now call f of x. So we have f of x equals negative x squared plus 400x. This is our quadratic function, and it has a maximum x value located at the h coordinate of the ordered pair, vertex ordered pair, hk. Now, how do I know that? Because look, the a value is a negative 1 in front of x squared. If a is negative, that means this is an upside down sad face parabola. That means the vertex hk has got to be the highest point on the graph. So h represents the maximum x value. In other words, when I say the maximum x value, it's not the largest x value. It is the x value that produces the largest y partner. Now, we have a formula for calculating the h value without completing the square in f of x equals negative x squared plus 400x. We just use the formula h equals negative b over 2 times a. That will give us our h value, which is our maximum x value. Okay, so let's take the general form of a quadratic function, f of x equals ax squared plus bx plus c, and compare that to our f of x equals negative 1 times x squared plus 400x, plus 0 at the end. That gives us a equals negative 1, and it gives us b equals 400 when we compare those. So that means our h value, plugging these values into the formula, is negative b over 2a, so it's negative 400 over 2 times negative 1. That simplifies to h equals 200. So we found the x value that produces the maximum y partner. Therefore, the maximum area, now remember, we called f of x our area, and when we let x equal the maximum x value for the function, which is 200, that will give us the maximum area. So we're evaluating the maximum area by taking the area function, f of x equals negative x squared plus 400x, and we're letting h equal 200, or x equal 200, to get the maximum area. So f of 200 equals negative parenthesis 200 squared plus 400 times the x, which is 200. and that's negative 40,000 plus 80,000, and that gives us a total of 40,000. So the maximum area for this movie screen that's going to have these blinking lights on it is 40,000 feet squared.